Maya, once you can hear us, please let us know. Maya, have you been able to fix your audio now?
I'm not sure there's anything wrong with the audio.
No, have been calling out to you before now. Your mic was not enabled before.
Okay, sorry.
No, it's okay. Good.
Yeah, good evening.
Right, good to have you.
Thank you.
So we're also broadcasting on YouTube.
Okay.
Um, so we'll just give about 5 minutes to start. Some other people will be joining live on YouTube. So we'll just give about 5 minutes, then we'll start regardless. Since
Right.
we are also live on YouTube, some other people will be watching on YouTube. Hi, Razak. Good afternoon. Um, I'm aware that you may not be able to talk, but I've enabled you to talk in case you want to talk. Hope you're doing great. Um, so I've enabled your mic. So we'll just before you join Razak, we're talking about giving about 5 minutes grace for more people to join the webinar, and then we will get started. Good to have you on the call. All right, we have 2 minutes to go. Once it is 5:05, we will get started on this channel. Is that okay, Mayowa?
Yes, yes, that's fine.
All right. Oh, thank you. Let me see if I can pull music, and so this space doesn't get too quiet.
Please, can I try to test sharing my screen?
Yeah, sure. Please go ahead. Don't worry, you'll have chance to be able to share your screen. You were configured as an equal organizer, so you'll be able to share your screen. Right. So it's 5:05. Let's get started. So Maiwa, don't worry about it. You'll be able to share your screen. Don't worry.
No, it's because of my system setting actually.
Well, we can see your screen.
Okay, thanks.
We can see your screen. All right. So let's get started. So we don't spend over time. Hi, Alex. Hi, Olafui. Good afternoon. All right. We were just about time. We were saying that since we're also broadcasting on YouTube and some people are already on YouTube, we're going to just start here already. So welcome and good afternoon, everyone. And hope we're having a fantastic weekend so far. Um, my name is Odo Atayo. I'm the CEO and founder of TechLitics. I'm just going to be here briefly just to do some introductions. Then I'm going to pass over the mic to Mayo, who's our expert guest on the show on today's webinar. And on the call with me is Ian Olua. Ian Olua is the program manager here at TechLitics. So while we're starting, I'm happy. I'd like to hear from us. If you can unmute your mic. I know some people may not be able to unmute their mic. However, I'd like to know where we're joining from. Olaf, we have challenge reconnecting. I'd like to know where we're joining from. Anulua, Paul, Alex, there was Razak on the call earlier. Is it still on the call? So you have the ability. You should have the ability to speak into your mic right now, or alternatively, you can just put it in the chat room that you're joining us from Lagos, or you're joining us from Jos, you're joining us from wherever you're joining us from. Okay, so while we're doing that, also there's a poll, there's a poll that should have popped up on your screen that is literally asking you, how familiar are you with large language models? Again, this is a webinar, it's an information session, it's a practical session, it's a no judgment zone area. Nobody's going to say, don't you know? Yeah, who's speaking?
Yes, okay. I'm Dadara.
Hi, good evening.
I'm joining from Dr.
Sorry, I didn't get that.
I'm joining from Dr. Lagos.
You're joining from where?
Dr.
Dokpemu. Did I hear Dokpemu? Welcome. That's in Lagos. Welcome. All right. Thank you so much. Thank you, Alex. You're joining from Lagos. Almost everybody here is joining from Lagos. I know Luakwa is also joining from Lagos. All right. So you have a poll. You have a poll in your DM or on your screen, and while while I'm still waiting for people to take their poll, I'm going to publish the results and it will update itself as time goes on. We kind of have some fantastic people in the room. So because, hey, going by the average rating I'm seeing on the poll here, you should also see the poll result on your, you should also see the poll results on your screen now. The average rating is 4 out of 5. That's, I mean, if the weight of 4 out of 5, that is fair. So today we're going to be talking so much about LLMs. Again, I'm not going into any conversations. When Mayowa takes it over. My job here is to do the introductions and I'll do the honors. So please let me know once you can see my screen, and then another 2, 3, 5 minutes, I'm out of your face. All right. Please, if you can see my screen, give me a thumbs up, thumbs down. So that I can know that, so I'm sure that you can. Okay, I see the thumbs up. Thank you. All right, so welcome to Techlytics. We're building Africa's AI-ready workforce through practical, hands-on technical education. One thing that we're known for at Techlytics is that we are focused and we niched down into data and AI. It has always been from the beginning. We started first few courses in data analytics and data analytics related tool, or even data analytics related programs. So yes, that is largely what we do, and all our programs have been practical, hands-on, and they are technical. Right, so today I'm just going to give us a brief of who we are. We are a hands-on technical education program built for Africa. Africa has its specific challenges, its specific nuances that nobody else will solve for us than us ourselves. So it was imperative, or it was important, that we come together. I mean, there are other fantastic places, or there are other fantastic institutes or education programs that were also doing this all together in the ecosystem. So yes, our approach is rooted in context. We understand that Africa's data landscape requires solutions designed specifically for our environment, our infrastructure, and our ambitions. Right, so basically that's what we're doing in our Techlytics. The problems we're solving is split into 3 broad categories: talent gap, infrastructure challenge, and education disconnect. Talent gap, of course, that screams. It's even almost all over the world. The tech talent gap, the data talent gap, the AI talent gap is there. So what we're trying to do is to attempt to bridge that gap from time to time. And we're going to talk about how we are solving, or how we are bridging that gap. The other problem we're solving is infrastructure challenge. Now, somebody is wondering, well, you guys can't do the infrastructure challenge. We have a lot of problems around electricity, around internet. But hey, one step at a time, focus. So we're doing our best to implement systems and infrastructure that can carry things, or alternative systems. I will use the word alternative systems and infrastructure that can help us implement efficiently. There's also an education disconnect. That is, we have universities, or largely tertiary institutions, who are producing graduates that are not readily equipped for the data and the AI economy. So how are we solving this problem? 3 major ways, actually. We're doing corporate trainings for data programs. We have enterprise AI labs, and we have university AI programs. What corporate training largely entails is that before you can even start thinking about AI at all as an enterprise, your data literacy in-house needs to be fantastic. It needs to be great. When it comes to fragmentation, you've gotten your fragmentation together. You have a unified source of truth. When it comes to data cleaning, you have a pipeline of ready to use data, or if you have a data warehouse that is. So when it comes to data engineering, anything that has to do with data literacy or the entire data domain, that is what we do on the corporate training side of things. But for enterprise AI labs, we see that a lot of enterprises, private and public, they are trying to implement AI strategies all over. Almost all the roadmap contains AI strategy, but they lack the necessary resources and talent and knowledge to do these things. So that's number 2 way that we're solving the problem. So we come in to We come in to be their training partner. We come in to be their implementation partner. Also, the last is the University AI program. Don't forget the bit I talked about education disconnect. That is, we have a lot of graduates that we're turning out in our tertiary institutions who do not have the ready skills to, to face the challenges ahead. So that is what we're trying to do. We're trying to create a pipeline even from the university. So we are trying to prepare the next generation of talent so they can be workforce ready. All right. So why do we do this? We want accessible data like literacy. We want to break down silos, and we want contextual solutions to our problems. I mean, thankfully, almost everybody on this call, as at the time I took the poll, or as at the time I took the intro, everybody lives in Nigeria. We have specific problems that have been plaguing us since forever. Case in point, we have our national grid issues that, I mean, we can optimize things better if you ask me. So we have specific problems that probably are not, they wouldn't experience it in the first world. But hey, we're still in a third country, or is it in a third country world, and we have our own contextual problems that requires contextual solutions. All right, this is the team. This is the team here at Techlytics. These are fantastic people that were driving this innovation together. All right, so now to our guest speaker who is also on the call with us. His name is Mayowa Dioni, and again, I would not take this this time for granted, because Mayowa is a full stack engineer at AC with over 6 years of experience bridging the gap between machine learning and robust full stack development. He specializes in inference economics and the deployment of production grade autonomous agents in secure environments. At Ascent, Mayowa architects multi-agent systems for real-time orchestration and secures privacy-conscious MLOps pipeline. His technical expertise spans end-to-end infrastructure, from optimizing model performance with frameworks like JAX and TensorFlow to deploying containerized local LLMs using Ollama, and that's what we're discussing today. Mayowa's work centers on the practicalities of making generative AI work at scale. It helps organizations achieve high ROI through local first deployments that prioritize data integrity and operational safety without sacrificing speed or intelligence. All right, ladies and gentlemen, please give a round of applause. I really like us to see our reactions. Give a round of applause for Mayowa. Don't worry, I'm giving Mayowa his mic right now. All right, we're all familiar with the topic already. Deploying local LLMs with Ollama, model selection, and inference optimization. Of course, we all, maybe not all of us, but as Mayowa is teaching us, we would learn. All right, a few housekeeping rules. We welcome questions. So if you have a question, you can raise your hand, or you can put it in the Q&A section that you see on your screen. So please feel free to drop it in the chat. Yes, you have the recording of this video available. It will be hosted on YouTube. In fact, right now it's being hosted, or it's being streamed on YouTube. And also, you have to stay with us on social media. All right, so here is where my work stops, and I'll be handing over the mic to Mayowa for the next 1 hour and some minutes thereabouts. All right, so Mayowa, you have the floor. Mic check. Mayowa, can you hear me?
Yes, I can hear you.
All right, boss. So over to you. I'm going to stop sharing my screen now, and we can get started.
All right. Okay, I think let me just share my screen. Just 1 sec. Please confirm you can see my screen. See my screen? All right. Okay, so good evening, everyone, and thank you for joining today's session. I want to thank the organizer for the opportunity and the privilege to get to talk in this workshop, right? So today's session really is about deploying large language models locally with Ollama. That is like the title of the team, with a focus on air gapped or restricted environment, basically. So, I mean, I'm sure some of us here are like gurus and we have an idea of most of these things. So it's going to be rather a more practical session. Not really about talking about how impressive AI models can be. We focus more on how they can be deployed safely, predictably, and responsibly in a regulated environment, right? And our focus will be more of healthcare and financial services sector, right? So next slide. So this is how this session will flow. We begin by grounding ourselves in what air grip AI means, and then look at enterprise use cases for local LLMs. And after that, we discuss model selection and inference optimization strategies before moving into a live demonstration, and then we get to like do a kind of question and answer. Please, sorry. So we get to do kind of question and answer for anyone that have any question. All right. Well, why air grip AI? Really, like I said, what it just means is deploying LLM in a restricted environment. So in many organizations, right, and with a keen interest in the context you are going to be considering this evening, in healthcare, in finance, let's say even government, the biggest constraint really is around whether people should adopt AI in sectors like that. It's not really about whether AI is capable or not, right? It's majorly about risk. I mean, you cannot expose sensitive data um, on the cloud. For example, recently I mean, working on a project with a client in also a very sensitive sector. And one of his concern was that he doesn't want a scenario whereby data is being transferred even with Google Drive at all, or even hosted on GitHub. He wants that data to just stay and live, right, on his system because of a lot of privacy issues around how most of these big organizations get to like control or manage our data or even use our data, basically. So we cannot really um we cannot be so sure or certain about how sensitive data will be used, right, in a kind of cloud infrastructure system, right? When you expose your data on the cloud, it kind of introduce concern around data exposure, regulatory compliance, I mean, and how your data is being audited, right? So, and that's why it kind of land the key question about how do we deploy useful AI system without exposing sensitive data? I mean, many of us probably use most of these common LLM that is on the cloud. We go to Gemini, we go to ChatGPT, and then we kind of put our personal information there, right? And I mean, whenever you go on any of these platforms, your responses or your prompt and then the responses by the AI, right, is being used to train their model, right, and make their model actually better. So I mean, imagine putting very sensitive stuff about yourself, then that means I mean you don't just know AI can come and then expose that data to someone else, right, that you don't really want the person to number. So the reason about using air grip AI is how we can actually access AI or LLM, right, in a control setup, in a control environment that is not necessarily it's not necessarily you can be so sure that nobody really is going to like have access to it. So let's really talk about what is a gapped AI. What is it really about? So when we talk about air gapped AI, we are not talking about something really theoretical, right? In that sense of it, it just means we are deploying AI model entirely within a control infrastructure, right? With no external data transmission. So many times when I want to like explain this, I try to use this example of okay, you have Google Docs and then you have Microsoft Word, right? Everything you type on Microsoft Word, right, lives on your system, particularly when you don't like connect it to any cloud. You don't sign into the cloud to back up your data, back up anything you're typing. So I just see Microsoft Word like an air grab system whereby you have control over anything that you typed and everything that you type actually lives on your system. And then see Google Docs as a cloud infrastructure whereby what you type there is backed up in the cloud, and because it's on the cloud, you can't be so certain that you are the only one that have access to it. All right. So basically we can say that um is a setup that we own, that we can operate, and then we have, governance over. All right. So what are the common enterprise use cases? In healthcare, for example, there are a lot of use cases, more like doctor get to like type or write note about a patient, and then you need that AI to like summarize all of those jargon, or you want to have like internal knowledge retriever about maybe a large document, and then you just looking for a particular information from that document, and you don't want to expose that information because it's sensitive to the cloud, right? You can get to like use these locally deploy LLM, right? And most of the time when you are talking about using this setup, right, or this system um in your own use, in this particular use case, you are not necessarily using it as a for diagnostics. If you go to any of these even cloud AI system, they tell you that AI can make mistake, right? Don't actually bank on the information. I don't know if any of you here, right, has actually interacted with this AI, and then it's giving you information with so much hope and assurance, and then eventually what it's actually saying is not so accurate. So because of how you can't just have a medical issue now and then you are telling AI about okay what you are having, it can only just give you suggestion. Eventually it will tell you like get to like see a doctor. So it's not there to like replace humans. Is actually there to like help them, to assist their operations and their work. Also in financial setup, financial services, this um locally deploy LLM can actually be used to like retrieve information, to summarize stuff. To give you drafts about a document. And we're going to see an example of that when we start our live demo. All of this is just like an intro to what we are to be doing, or what we'll be doing today. Okay, so why Ollama really? Why are we talking about Ollama? What exactly is Ollama? So Ollama simply is a local I would say local inference runtime. What it allows you to do, and which I'm going to also show us, is that it allows us to like download, it allows us to run and manage large language model entirely on your own system, on your laptop. So for example, you go to Gemini, right, and you put in stuff on Gemini, you need an internet access for you to access Gemini, to access ChatGPT, right? But with Ollama, you can download any available models there. I mean, if it was a physical session, I would have actually put off my data, and then you see how we kind of retrieve information with these Ollama models. And so, but if I do that here, I mean, I will be disconnected from this session. So we can entirely run this model without internet access, and it gives us information based on any context that we provide, or based off our point, basically. So from, I mean, an enterprise perspective, this is important really, because using Llama, right, any of their models, it allows us to like experiment and deploy data, right, deploy stuff without actually sending our data to any external service or any cloud service. So what it just does is that its value is majorly in about how is very practical, how its response are predictable. Yes, it can be very boring, right? But that's why, and that is exactly why it's needed in a regulated environment. So let's talk about model selection and what really actually matters when you are selecting model, trying to build with this kind of setting or setup. All right. So when selecting model for sensitive environment, I mean, benchmark are really the most important factor. Uh, what matter more are things like latency, that is, what is the runtime, what is the time that the model used to like respond, how fast it is, how predictable is the response, not necessarily about how creative it is, right? I mean, you can go to AI and then type stuff, and then it gives you a response in a very creative manner, even though, I mean, you don't structure your points, just can be very creative in how it generates information for you, right? Another thing is how explainable it is. And then the last thing, right, is about hardware constraint, right? In regulated environments, we don't pick model first and buy hardware later. By hardware, I'm talking about the system, the setup, the laptop that you're kind of using to like run your model, right? We pick model that fit our hardware. I mean the hardware that we have and we already trust. You can't just run you can't just download any model and then run it on your laptop because you have a laptop. I mean, it might not work, it might crash your system, it might be very slow because your system, I mean, your system laptop hardware configuration doesn't really support the kind of model that you are trying to use. So in many instances, right, um, a smaller web beef model is preferable to like a large, more creative one. And the best model is not like the smartest one. The best model is the one that you know that for your own use case is reliable, for your own use case is auditable, for your own use case. I mean, it's fast enough. Okay, so let's see inference optimization in practice. So I mean, when we talk about inference optimization, we are not really talking about making models smarter, right? We are talking about making them usable in real environment. Okay, so I mean, let me start by saying what inference is, and if you know what inference is, you can also probably type it on the chat, and we can look at it together whether you're right or not. So inference is simply the moment when a model takes an input and it produces an output, right? It takes a data and then it gives an output based on the data context that you fed it with. And then optimization basically is really about ensuring that this process works right within our reward limit. Remember what I told you about the time, the literacy, right? What I mentioned about the hardware, risks, and then cost. So let's start about talking about model size choice, right? I mean, a model size or a model usually refers to how many parameter a model has. Now, when we talk about parameter, we are talking about how large and how complex it is. Already, we know that a model is a large language model, but then there are very there are models that their parameter are, I mean, smaller than other ones, right? So, larger model can actually capture more patterns and nuances. But then they also require more memory and more computation. That is, they require more memory and then they require more computational size, which is really more about hardware constraint here. So a very large language model need tens of gigabyte memory and specialized hardware to like work, right? And a smaller model can also run very well on a standard CPU. Now a CPU is like I mean central processing unit and it's what really does the actual thinking and calculation. I mean, that is not really the focus here. So don't let me go so much depth into that. Um, so practical optimization levelers. Another thing to know is quantization. I mean, let me just explain that in a very simple way that we can understand. So you know this stuff whereby people post their pictures right on WhatsApp status, and then the next thing is that WhatsApp actually reduce the photo quality, and then you have your friend tell you that send me this picture in a document format. Why? So that the quality will be preserved. However, it's also possible to send an image to someone on WhatsApp, and then WhatsApp get to like um reduce the size if you have not like I mean added this setting to like tell it not to like reduce your size and what have you. So you are sending a photo of you on WhatsApp. Now the original picture, notice the one that you usually send using document format is usually very large, right? But if it's just with an image format, right, WhatsApp reduce the size so that it can send, can be faster, right? So, and whether it's faster or not, I mean, sometimes you picture you still see what you want to see, but it might not look finer anyways. But it's just like a lighter version of the one that you sent via document format. So quantization does the same thing for AI model. So instead of the model using very fine, large, precise number all the time, we are allowed to just use a very small, slightly smaller numbers. I mean, numbers that are very small so that it can run faster, and then so that on our system is also going to run very well on our laptop, right? Um so yes, I know many of us um go into want us to like go into the live demonstration, and really that is essentially my focus this evening. So in this live demo, we are going to actually build two small realistic system, one for healthcare and one for financial system, entirely offline, right? And the goal is not really to show how impressive model are. The essence is just for us to see how intent constraint right shape AI behavior basically. So I think I can stop sharing this so I can share my full screen um so I can start the demo. Please confirm you can see my full screen if you are still here. I just give a thumbs up before I switch. All right, thanks. All right, so let me just clear this. So basically, this evening, just don't mind that I've put in some folders and then put in some files. I don't just want to start typing from the scratch because of time, right? So, but I will take it in a very simple way so that this can all make sense to us. So I want to start with the simplest example possible, and I will just be using my terminal alone. And what this will allow us to see is really to see what is really happening without any abstraction, what have you. So, I mean, the first thing is to like the first thing is for you to download Ollama, and then you can download Ollama by going to their website. You download it on your system, and then once you have downloaded Ollama, we will not be going through me downloading Ollama models for you. I expect you to like have it, but you can list Ollama, that is, list the kind of Ollama models that you have on your system, just Ollama, and then list, and then it's going to tell you all the models and then the time that these models were kind of downloaded, right? So like I mentioned to you, um like I mentioned to you, these models can actually work offline, right? You don't need any internet access, and it's as though you are talking to like your Gemini, but just from the comfort of your system. So the first thing I want to do is I will do run Ollama run, and then I'm going to pick any model. So let me just pick this, right? And then I run it. It's going to take quite some time. So it asked me to like send the message. So let me send the message. For example, this is completely offline. Now it gave a response. It said, "Hello, how can I assist you today?" So I can ask any question. I need you to summarize a document for me. All right. It says, certainly, please provide the text of the document that you would like to condense, and let me know if there's any specific aspect or angle you want emphasized in your summary. This will ensure I tailor my response effectively. If no further details are needed, just send over the main content directly for summarization. Do you see that now? So let me just start with a very simple I start with a very simple um clinical note, right? So I can say summarize the following clinical note for me, right? And I can say, okay, so let's start by saying a patient is 20 years, 20-year-old male, with chest, issues, no shortness of breath, dizziness, loss of consciousness, etc. So let's see the summary it comes. I mean, the summary, my stuff is quite short, so the summary is probably longer than what I even expect. Now, let's read through the response, which is also going to like help me to like explain some of the things I want to like talk about this evening. So I get a very short stuff. I mean, see my notes. So I should summarize this just one sentence, right, for me, and then see how long the summary is about. It says The patient in question is 20-year-old, presently chiefly and unspecified chest issues. Said despite the absence of symptoms such as shortness of breath or episode leading to dizziness and loss of consciousness, further details are required for an accurate summary to be beneficial to know more about this, initial duration, intensity, any associated symptom, past medical history, results, current medication being taken that might influence symptom, any lifestyle factor, and it says finally, without additional context and information from this document full content, a precise summary cannot be provided at this time. So you see the importance of data context, and you also get to see the importance of prompts, right? A system prompt that we set so that we can guide the model. So I mean, this is just a basic way to interact with model. You're just asking for a summary. Now, one of the things is that this actually works, right? But we have not really, and that's why you see it just give unnecessary response. We have not really told the model what is allowed to do, what it must not do, and how to behave. So in a regulated environment, this lack of structure is actually a problem. And that actually leads me to what is called prompt discipline. So want to like want to like um be so structured in our prompt so that the response from the model can be better. So let's see another example, right? So I have I don't know. So I have this. Let me get so I have, let me just copy this. Clinical note. All right. So I have these notes, and then we are going to define this. So we are going to define our constraint. So let's send a message. You are a clinical documentation assistant. So this is me just giving it rules, right, to follow. Do not diagnose, do not recommend, do not include patient names, although we can leave that for now. Refer so summarize the clinical note below using factual language only. So I will just copy this and then I will paste this. So let's see and note the difference in the response. So notice what I'm doing here. I'm not asking the model to be smart or to be smarter. I'm just guiding it. Now you notice that the summary here, right, is way shorter than what we have here, right? Because I gave it enough information, and I mean I gave it constraint, using my prompt of what he should follow. So it says the patient is a 50-year-old male who experienced this, blah, blah, blah. Now I can do another example, but I think we can just transition into using um a more formal system than all of this, and that's why we have this setup here. So notice I've told us earlier that everything that we are doing is outside of the cloud. We are not calling any cloud API. We are not using any external server, and all of this data is not leaving my laptop. It's not leaving our system. It stays right there. All right. So let's start with the healthcare system, right? So notice what I told us earlier, that clinicals or doctors write a lot of large amount of unstructured tests, which they call their clinical notes. And we want our AI agent, or not agent, and we want this model to summarize it, right, and just give us a summary of the unstructured text or the unstructured notes. We are not asking it to diagnose or give treatment recommendation. We just want it to summarize everything that is in that note for us, right? So let me explain what we have. So this data folder here is our raw input, and this is where we are going to have our clinical note sample. So I've just put a kind of sample here, right, for clinical setup. I'm probably going to do more and just for us to see how it works. And then this is just a financial policy sample test. So our data will be put here, right? And then prompt is where we set the rules for our model, what it is allowed to do and what it is not allowed to do. That is where we define rules and constraints for the model. And then the app folder, right, that is application logic, allow data to flow into the model. So if you have any basic understanding of Python, that makes sense. If you don't, we are also going to maybe see how we can translate this using our terminal, just like I have done, right? And then our output is where we tell our model to save any output to generate for us. So this separation is actually very deliberate. It's just to keep our system in a very structured format. So we have data where our data is, output where the output of our response it gets saved, prompt where we set up our prompt, and then the app folder where our logic actually stays or lives. So let's see an example. To see this, all right. So here our prompts as so I see a prompt as a contract, and our prompt as our system instruction where we kind of define the role of the model. So we said you are a clinical documentation assistant operating in a regulated healthcare environment. So we define the role of what the model should take. So the model is acting like a clinical documentation assistant, right? The next thing is that we set some rules, right? Some constraints, and we said you must be natural, and strictly not diagnostics. That is, if we don't set this rule, it's possible that because these models can isolate, it can just be very creative. So we said ensure that you are not giving a diagnosis based on the data that is being fed into it, right? And then the next thing is do not infer condition, causes, or treatment, because models as they have that tendency, like I said earlier, to be very creative. So we are setting the rules of how we want the model response to behave. We said, do not introduce information not explicitly stated in the clinical note. So you see that the importance of your prompt actually change everything literally. It can affect how the response is, how the response, the output it gives you, and it can make the output actually better. So we also said if information is missing, state that clearly without speculation. So don't try to like imagine or try to like fill up the gap. Let us know that okay, this information is not provided. So the next thing is that we said summarize the clinical notes using the format. So give summary, give key observation, let us know if there's any missing information and compliance notes. So all of his outputs, all of the summary that it's going to give us will be based off this, right? So we now set, I'm going to tell you what this is just us now setting the data, right, inside the prompt. So end the response after the compliance notes, and I mean the compliance notes actually ends here. So so every single line, I mean every single prompt that we have here can actually, I mean, change a lot, can affect a lot. So so the first thing we will do, maybe I should run us through a bit of this. So I'll just cancel this. So like I mentioned to us, I can list the models that I have, and this is one. All right, and I'm using this as my model name. So this is the model that we are using based off what we downloaded from Ollama. So the next thing, just let me try to explain all of this one after the other. Okay, so this is just to ensure that any warning is ignored, is not showed. So we have our notes. Our note is our data, and the data is defined right here. We have it under display. So this is where we give information about the patient is a 54-year-old male presenting with this over the past 2 days. Past medical history include hypertension. So basically, a doctor will literally write some of these, right? When they kind of have sessions with any patient. So no, so you see that they ask you questions when you go to hospital. I'm not a doctor, so maybe I might be wrong right here, but this I believe is what they do. They ask you questions, okay, when last do you feel this, felt this, or do you have a headache and all of that, and then they note all of that. So vital signs on admission were within normal limits. ECG was performed, results were pending, and this note was written. No laboratory result according to available. Patient was advised to remain under observation for further evaluation. So this is a doctor note, right? So we define this variable and we set the path to these notes that we have, right? And then the next thing is to define a variable for our prompt, and then we set the path, right? Our prompt is right here, structure point, right? And that is where we have defined all of our rules to guide our model. And then the next thing is that for our prompt, we tell this Python program to replace anywhere it sees clinical notes like this with the prompt that yeah, to replace it here with clinical notes, and the clinical notes is actually here. All right, so inside our prompt, where is it? Inside our prompt, we set the clinical note. So all the and everything that the model is doing is based on, so it's just basically summarizing what is in this note, right? And then the next thing, of course, basically you can see this is localhost and this is the port of the model, right? So just tells you that nothing is actually outside of your system. Now, if I want to interact with OpenAI, OpenAI has an endpoint like as like this OpenAI something. I mean, this is as though I'm connecting this information to OpenAI model, right? But this actually everything stays on our system, stays on the Ollama that we have downloaded and it's running locally on our system. So payload is just the data that we are sending to the model. We are sending the model name where of which we have specified here. You see that I imported config here and I import my model name. So what model name are we using? We are using this, and we are also going to like try to use different model and see how they behave, right? All right. So we are also setting the prompt. So the prompt is what you have seen here, right? And then stream is false. So this is just to print like the model. It will tell us the model that it's using and tell us that it's running locally on this port. And then it's kind of do a kind of record just to make us see the time of output that it takes for the model response to be generated, which was what we call the latency, right? And then we set our response. So in our response, the request is a post request, and we are specifying the URL. The URL is what we have defined here, and then we set the payload inside this, right? And then latency is like what is the time now, and then the start time. That is the time the response started generating, and then the time it stopped generating. And then the next thing is that we tell it to like save our output here, right? So I just want to just let us see this so that we see how it works. So basically I can run this using Python 3, say run inference, right, dot py, and then we are going to be changing different stuff so that we can compare the results at different times. So sorry, just want to clear up this. So Python 3 run inference. Now the name of the file can be anything. This is just what I want to use. All right. Sorry. Oh, sorry. I need to do this app. So this file is under the app directory. So that's why I gave that error. Okay, so this is just normal warning, so you can ignore that. It's running now. So note that the first thing it printed out is running on this model, and the model is what we specify here, right? So now it gave an output. So it tells us the model, localhost, and what is the output. So let's see the prompt. And I can open this note. So what is the data? Yeah, at the side also. So I can just compare the prompt and the note. So this is something that the model gave us. Said a male patient age 54 experiencing might this that. He has a issue of hypertension but no drug. The patient shares discomfort is non-reacting, lasting several minutes at interval without the presence of shortness, breath, or other severe symptoms. Vital sign and normal EGC result pending hypertension as a result of medical history. Notes, no allergies reported. Complete interpretation of EGC result, no allergies. Just a summary, and note that this is what I guided the model. I said, give me summary, give me observation, right? Gave it in a bullet point. Give me if there's any missing information, give me that, and compliance note, right? He said all of that. So let me add something. So the first thing is that we see that this will be saved under so this will be saved under this output, right? So everything that we have here is what. So I want to like use something else. Let's say true, and I will be adjusting the prompt and then a few information about the sample. So maybe I should use another sample. I just make a duplicate of this. So maybe I should call this true, right? Now instead of patient, right, I want to use true, or let me say Shade, right? Now this is a patient name, and one of the issues, like I mentioned to you, is that we don't want to like feed this model with the name, or even though they are feeding into the name, we want the response to like not include the name, because this is a very sensitive information and there can be more sensitive information in this stuff. Now the age is there, the name is there. So let me say maybe Shade Adebayo. I don't want to believe there's anybody like that. So in my prompt, right? My prompt is here. So I'm using this. So I can say do not include the patient name in your response. Use patient. I can say it should add code the name with something else, right? Do not include the age. Use asterisk, right? So so the next thing is that I will just set my data input as this, which is what I have here. Consider I've like tweaked that, and then the prompt, I've also like added new information to my prompt. So let me run this again. Let's save this also. So it also tells us the time. So it ran for like 16 seconds. So let's save this. Okay, we are saving it to latest output 2. So I run this again, and then we are going to see the response, the difference in the response that we had and what we have now. This ran in about 10 seconds, so that's good. So notice that in my clinical notes, I included the name. In the output now, it's not including any name. It's a patient present. In fact, I can replace everything here. Any mention of patient, right, with that full name, and you are not going to see that. All right. So I can run this again. Let's wait. So this gave you response in 2 seconds. Right. So let's see what it says. It says patients identify as Shade Adebayo asterisk. That is the age. Based on what I said. Of course, I can make this better. Just say age with asterisk, right? So any little change to the prompt affects the response.
Hi, Mayowa.
All right.
I don't know if you can hear me, but I'm struggling I can't even hear you at all. I don't know if anyone else can hear you.
Any other person hear me?
But yeah, I just wanted to say that.
But can any other person hear me, or you are the only one experiencing that?
Hi, I can hear you, Maiwa, but it will be okay if you can project a bit louder, but I can
Okay.
hear you.
All right. Thanks.
Alex, how about now? Can you hear him well?
Hi, Alex. Can you hear me better? I will just proceed. So we get to see the response or the output. Right. It says the patient reported this. So in the response that the model gives, there is information about there's no information about the patient's what is it called? The patient's name at all because of the prompts that I have set. So we can be as creative as possible. I mean, based on anything that we want it to do. So I mean 10 seconds is fine, or 11 seconds is still okay. So I will just move into financial services. All right. So I mean we are going to be looking at same constraint, maybe different intent, right? So so in our config.py, I'm going to use another model. So let me just list my model and then replace it with anyone. So I'll be using laboratory latest. All right. So instead of all of this, I'll change this to that. Okay. And then I don't want to like edit my code so much. So I want to be able to switch between health use case and then finance use case. So I will set a variable as finance here, and then I will go here so that I change a few things so that I can be able to like switch between finance and I mean medicine, if that makes sense. So so I will tell this if use case. So I need to import use case. If use case is healthcare, right? We should use, so I'll just copy this just save time. So instead of clinical note, I just change this to note. Then prompt, template. So instead of clinical note, I will change this to note. And then the next thing, if we have if, I mean, let me clean those others so that you can see my screen better. All right, so next is else if use case is finance. So we can define multiple use case, right, and get our code to the work. So for this, so instead of clinical notes, we are going to be changing it to finance policy. So the data part is still the same. So which prompt are we going to be using? So yeah, we're using this. I'll also walk us through that. Right, and then instead of this, if you go here, you see we're using policy test. So we say this. To see why. Okay, I think it's indentation. All right, so yeah, so I can go here and then do it here and then run it. Sorry, it will still give me the response will still be of healthcare, and then if I change this to finance, the response will be based on that. So let's just see that that works. And right, so you can see I'm using a different model, and you will note that the response is different. So this seems brief and not so much information, right? So let me just switch to finance, which is my focus. All right, so I get to run this. Wait for it to run. So that's sorry. Um, that took 17 seconds. So let's go over our finance maybe note or sample note, and then get to like see the prompt also. So the first thing is that we said you are internal compliance analysis assistant for a regulated financial institution. So one of the first thing that you want to do to set the tone is that you want to like give this model a kind of how you want them to like act, right? You want to like define, okay, I want you to like act in this way, in this manner. So we are using same, I mean, it's still Ollama, your data is still not outside there, it still lives on your system, but we have different intent. So, and of course, you observe that in a financial system, knowing what is missing is more valuable than I mean what is present. So um so we say you are an internal compliance analysis assistant, you must be factual, conservative and non-advisory. That is, don't try to give any advice. Do not provide legal or financial advice. Do not introduce assumption or external information. Use the content provided in the policy excerpt. Summarize the policy using the format, summary, document, identify risk gaps and compliance notes, and the response after this. All right, so we said this is our policy test. So we said this policy governs third-party vendors access to internal knowledge. I mean, in a ID setup, this note will be quite more than this, right? So one of the things that we see here is the response. The response also follows what we have defined in our in our, what is it called? We have defined in our prompt. So if I also change the model to another model, right? Of course, this model is many times is just based on their size, their parameters that they are used to train. So they are kind of intelligence differs. All right. So let's see um the response from that. So I mean inference literacy is how long the model takes to respond. You can see that the other ones that we ran in about 16 seconds, we got the response. This one is taking quite a number of time. In fact, it took 34 seconds. So those are some of the things that you might want to pay attention to when building a system. Of course, the response seems more, I don't know, maybe more more detailed, but you see the time that takes. So we select a model based on, I mean, your use case. So we see that this model still followed our prompt that we have defined here, right? It summarize obligations, right? Key obligation, identify risk, flag gaps without giving any advice or so what have you. And I mean that's just about that. So when we change the model, I mean we see different response. So we have been able to like see two different I would say two different industry, and it's quite amazing how it's quite amazing how like they respond. All right, it's amazing how with um different prompts, different parameter, we see different configuration, we see different um responses also. All right, so let's try to do one more before we go into our question and answer. So we can think about a setup whereby we have a data node, and now in our notes, I want to see how I can make this faster now. So I will just add this. I will add this. Okay. Remove this. So these are data. So there can be, you can also get to use this for, I mean, document retriever, retrieving information, right? So I want to like include some information that we have access to. So, Technetics is organizing a workshop on the 16th of January 2026. It's a 2 hours 2 hours workshop, right? We have 10 participants, 1,000 participants. So I kind of set this inside this long document, and I want my model to like give me like a response, like provide response for me. based on what I have here. So I will have a prompt. So I will say data prompt. All right, and just put it as a test here. Of course, I can put all of this inside this code, but I just want the code to be organized so that it can be easily followed. So so my data prompt is I need you to provide a one liner response to this to the following question. All right. Um, how many? Okay. Do not give unnecessary information. Just the response. Now, all of this, like I said, is happening on my local environment. Is on my local system. I'm not connected to anything on the cloud. So, how many participants are attending workshop? All right. So, I will say this. Hold on. As okay, so data test. So I can feed my prompt. So let's use another case. Use case maybe general now. I can just put this here so I don't get to type soon enough. Yeah. Okay, so under the note, we replace it with our note and then we set the parts of the data. So our data is here. So I copy this so that I don't get to make mistakes. No, that is prompt. So we have this prompt. All right, and for our data part, our part is in this place. So I copy this and then I put it right here. All right, so I'll go to my configuration. Because this model is slow, or it takes quite a number of time, I will just replace this with this, and then I will use general for this, right? Because I'm trying to, my context is just based on the general information. So let's run this now, and then let's see the response. I mean, I expect it to be faster. So 5 seconds. I mean, see the model response. Say 1,000 respondents are attending the exclusive workshop. Of course, note that that information just leave right. I mean, where is it now? Yeah, it leaves right here, right? So I can change my prompt and says that tell me what you know about what you know about. I think I saw Shade Adebayo, right? And then I wait for it to respond. 3 seconds. He said Shade Adebayo is a male with hypertension experience mild to moderate intimate stress discomfort, a observation pending ECG result and laboratory tests, complying with third-party vendor policy on financial data protection during tech leadership workshop. Of course, this quite is the model also trying to like as insulate because I did not mention in any of these notes that this happened during Teclitics workshop. So I can, of course, make my you just see how the model respond based off your prompt. So I can be specific, right? I mentioned earlier that we set the rule. So the rule is what the model follows. So I can say ensure you don't mix up context is different from the patient just with this one line, and then let's try to like see the response that it gives based off this, right, for second. So the response is different, right? It says charges very different, a male with hypertension, discomfort, under observation pending this, take the workshop, unrated contest, third party vendor policy on financial data access do not apply here. So you get to see that here it says it applies.
Hi, Mayowa.
Hello.
Yeah, okay, so I just wanted to let you know that you have 15 minutes left.
Okay. I'm aware, I'm also checking time. Thank you. All right, so like I said, the response here is different because my prompt is also different. So you can actually use this for a whole lot of stuff, particularly in a context that apply to you. So you can have like a data that you own and you don't want to like expose this data to like the cloud, and you just want to like perform specific want to be like perform specific tasks. So the first thing that you actually need to do is to like define your prompt. I mean, your data can be anything, it can be very raw, structured or structured text, but you need to like guide or give the model more like rules of what it should follow. All right. So maybe before we go to questions, right? Let's just see one more example. So I have a medical based model, which is the Meg Llama 2. So I want to be using this as my config here. All right. And then let's just see the response that our data for our healthcare setup gives us. All right. So this, and then when I run this again, let's try to see how it responds. So I'll wait. So now you will observe something that let's do something. So this data is saved here, right? So you go here, you see this data here. So I will change this to 3, and then I'm going to use a different model, and then you get to see. So let's go back to this that we were using before, and then we get to like compare the response or the responses rather. So I will just open this. Sorry, you said error. Um, so let's wait. All right, so you can see the response here. So I can just open this up. Um, all right. So I personally believe that the response that we saw here um is more direct and is more, I mean, specific based on our prompts, and this one is more creative. So you get to also see that the model selection that you use also kind of determine how I mean how your response can be. So let's go back to our slide as we take questions. Okay. Um so um so we just to summarize everything we have been doing. Um we have been able to like see that in a regulated environment that is set up. I mean, I don't want to like go into so much complexity of how this can be used, but I'm sure that with just these few demonstrations, you have been able to see that sensitive information, sensitive stuff about you, about an organization that you don't want um, those information to be exposed to cloud environments. You can actually have something built just for yourself, right? On your setup on your laptop, in a regulated environment, and then I mean the model give you a response based of that, and we have been able to see that our prompting also helps. Our model selection is also very important in doing all of this. And we are actually able to also see that how local LLM make privacy preserving AI practical. And like I said, selection of model is not just is a business and risk decision, not just a technical one. And Ollama actually provides and gives us like a strong foundation when approached in a very responsible way. So the value of local LLM basically is not that it is smarter, right? It just means that it is controllable. I mean, you have it in a control setup. You can get to control things by yourself. So I mean, right now, if anybody have questions, will be I mean I'd be happy to hear. I'm happy to like take questions. I mean whether they are technical or not. So I mean I want to hear your questions.
All right, thank you so much, Mayowa. Can we use our clapping emojis in the chat to appreciate Mayowa? Thank you, Mayowa, for breaking this down for us and explaining thoroughly. Thank you so much. So let's drop our questions in the chat box, and you can also use your mics. Let's ask our questions, please. Drop your questions in the chat box, use your mics, and unmute yourself and ask your questions. Okay. It seems like there are no questions. We understand thoroughly. I need to hear from us. Do we have any questions? We have few minutes left to take questions.
Can anyone hear me?
Yes, we can hear you.
Yeah, no one can hear me.
We can hear you clearly, Alex. Alex, please go ahead with your question.
Oh, sorry. Was that me? I got that headphone back like a few minutes later. All right, let me just go ahead with it. Maybe I'll leave YouTube for now, and I'll join back later. Question. Well, so Mayowa, thank you very much. That was insightful and also very very technical. Like, I know how to write some Python code,
Yeah.
so well that's also good for that. The question on the concept of air gapped AI is, while I honestly from your introduction from the beginning mentioned that this is done just to ensure data does not leave the environment. That's sensitive data, private data. It got me thinking, how about data coming into the environment? Yes, we are using a model, and okay, for use case of an healthcare system where you want to be sure that the model you are using is not biased against patients. The model that you are using is trained on the right data. And that comes from the outside. And the concept of here gap is nothing goes out, nothing comes in. So I'm quite concerned if maybe does the bias that the models has internally, does it not affect the decisions that you get from, the advice you get from such models, even though they are air gap in terms of data leaving, no data leave, but there is an inherent kind of information in it. Unless if the models itself they are trained on Earth data, they are trained on my data, I think I'll kind of be okay with that, right? So that's my maybe not a question but a concern. Right. The other part is the way I currently use AI. I, I first maybe I won't speak about that now. The second part is, how do I deploy this in a corporate environment? Because you have the AI on your computer, and in a corporate environment, would this mean that everyone in the company would have to have Ollama on their computer set up and all that, or like there'll be like a central place where Ollama is and everyone can communicate with it. Like, instead of having to deploy across hundreds of devices, all we have is just one deployment, and then everyone gets to speak with it. Right? Like, I'm interested in that, how to deploy enterprise wide. Then thirdly is what I wanted to say initially, which is the way I currently use AI and the way this user experience you presented it's so different, right? I would want to use Ollama, but I would want like a friendly user interface. I see you create so many use cases for healthcare and others, and I have to modify codes, I have to modify files just to get my information across. While the way I currently use it is I just reference my files, or I have like a UI interface and then you just upload files, it kind of understands what's going on. So for someone who would be using this in organizations and they're not technical, I have to say a bit of humor there. Yeah, so those are just what I wanted to share. But yeah, this is quite insightful, Mayowa. Thank you very much. Let me
Thank you.
switch to my YouTube.
Okay,
I hope
thank
you
you very
guys
much.
heard me.
Yes, I heard you clearly. Can I go ahead, Luatayo, to respond?
Yes, please. Why not? Ian is with you. Please.
Maybe not to respond also,
Oh,
but
no,
yeah,
no, no. Please go
okay.
ahead.
Yeah, so thank you very much, Alex, for your thoughts and then your questions, right? Maybe I will start from the last one, right? Yeah, so it's very possible to like have like a friendly user interface, just like even let me see if I can get to like demonstrate that. So Ollama itself, um as it were, I can open it on my system. I think I will just share my screen again. Just a minute. So Ollama itself has like I will say a desktop app whereby you can interact with it. But of course, what you are talking about is having like a say specific use case now based on what we have been talking about. So we can actually build like a backend service, build like a UI, and then connect our endpoint right to our UI, and then we can get response of that. So that is actually possible. I'm trying to like share, but it's not working. So concerning your first question, right, about if you are talking about air grabbed environment, and we say this doesn't get to go out, right? And what about what actually enters the model in a sense? Quite a very good question. And it just shows that we're following all along. All right. So the model itself doesn't actually enter the environment dynamically, right? Once the model is downloaded and once it is installed locally and then runs, right? Everything is actually in an air gap environment, right? Everything is within your control, right? After that point, nothing actually goes in or goes out of the model unless you actually put it there. All right. So does something, like you were asking, does something actually go into the model? Yes, something actually goes into the model, right? But in a very controlled way. And that's why we're talking about aircraft, AI. So initially, right, the model is pulled from a trusted source, right? Just like installing any approved software. When I started, I was trying to explain to you about Microsoft Word and then Google Docs. So, you trust Microsoft softwares because you can be so sure that this software are vetted, to a large extent. So when you install Ollama, right, you are saying that I trust the source. Of course, it's actually trusted. And once you get it installed once, right, everything called internet access can be removed entirely, right? So once the environment is air gapped, the model is actually static, right? The model doesn't learn anything, right? The model doesn't update itself, right? The model doesn't send data anywhere. The only thing it does is that it receives the input test we give it at inference time. All right. So the model is like a calculator. You have your calculator, you give it input, it produces an output, and nothing is really retrained unless we kind of store it ourselves. So basically, that is how it works. So I mean, look at LLM like the one we are using, do not actually retrain themselves on input. In fact, hardly you say you want to like get information about it based on what is, I mean, the best way to use it is, I mean, you are using it based off your own data, right? You are expecting a response based on your data. And you know, like we said, we have to also be guided in how we use it, such that we are not trying to like use this as a way to like I will say, generate or do something for us. Yes, it's doing something for us, but what it's doing for us is within a controlled environment. Um, we are retrieving information from it. We are not, so you are going to like, let's say all these cloud server now, cloud environment. You see people get, I will say, recommendation. Of course, this can give us recommendation, but in a controlled setting, right? This can give us responses, but in a control setting. So it doesn't even remember anything that you say. You can see that I get to like save the response, because in actual sense, it doesn't have a memory unless we kind of build memory into the system. So by default, once the process ends, right, the input is actually gone. Your input is not saved anywhere inside the model, right? Your response is not also saved anywhere inside the model. The response is just used. Of course, if you want to save it, you can save it. Like I said, it doesn't have memory, right? So if I continue it, if I'm trying to like continue a conversation, right? It might not actually remember what I've said in the past, because I have not built memory into it. So and that is why we are talking about this concept, and that's why we are saying that aircraft AI is attractive, right? In a regulated environment, we control when the model environment, we control when the model enters the environment, what data it sees, right, and what happens, right, to the output. So 100% I can tell you that nothing leaks by default. Everything is actually a split, right? So that is about it. So really, AI is not about trusting the model. It's just about controlling the environment. And I'm saying that everything stays within your environment, that is your setup. So I mean, your second question, right? You mentioned about how can we deploy this in a corporate environment, right? Whereby does everybody have to like install Ollama and what have you before they use it? Well, I will say that in a corporate environment, deploying local LLM is just like deploying any other internal tool or internal service. So the model is installed, let's say, on a laptop. I mean, in a setup, of course, let's say you are also building an enterprise system whereby you want other people within a corporate setup to like have access to it. It's possible to like also deploy it I mean to the cloud, but then that's also bears the question about what we are talking about regarding privacy and security. But yes, that is quite possible, and there's a way we can expose any of the model, right? Val There's a way we can expose any of um oh there's a way you can expose any of the model, right? Val like cloud services, but based on all the instructions that we have set it. So I mean the only difference here, right, is that AI runs where the data already lives, not in the cloud. And that's what really we are it's enough for many people. So if you want every other person, let's say within a corporate setup, corporate organization, I want to believe that your data across your system is kind of connected together. You can access data across your system. And once everybody has Ollama installed on their system, and then they install the specific model that, I mean, you get to like choose. I mean, anybody can just use it in that setup. So I believe that answers your question. So over to you, Ratayo.
All right, thank you so much, Mayowa. Thank you, Alex. I hope that answers your question. Do we have more questions? Do we have more questions? All right. All right. So we know that there are some like technical difficulties with Zoho, so we might not be able to collate all the questions live, but we can still send in your questions. Thank you so much, Mayowa. Thank you everyone for joining in. Thank you so much, Mayowa. Thank you for your time. Thank you, Anoluwapo. Thank you, Alexander. Thank you so much for your time. Thank you for joining us. And we hope to see you upcoming webinars. We'll keep you posted. So you can follow us on our social media platforms, Technetics, on LinkedIn, on YouTube, on Instagram. We'll be having webinars in 2 weeks' time. We'll reach out to everyone, and you'll be getting the recording of today's webinar right after the call ends. And before we go, can we just take this quick poll? How would you rate this webinar overall? You should be able to see it on your screen. Would like to see the results. Oh wow, 5 star. Thank you so much. So that means my award did justice to today's teaching. Thank you so much for the feedback. Right, since we do not have more questions, can I see? All right. That is the end of today's webinar. Thank you, everyone. Thank you for your time. We really appreciate. Bye.